Hello and welcome to Redstone Hero, Episode 1. So, in this series, I will attempt to explain Redstone and how it works and what sort of fun things you can do with it. There are a lot of videos out there of people showing off their builds, and they take you through a tutorial and they tell you how to build it, but a lot of these videos don't tell you how any of it works. So, most people have to learn Redstone by tearing other people's contraptions apart, which is fine, but I always thought I would have benefited more from seeing how everything works and how it goes together when I was learning, so I figured I'll share that with everyone else and hopefully it'll help some people out. So this series is going to start from step 1. I mean, you've mined the redstone out of the ground and you have no idea what else to do with it. You know, it looks kind of interesting, it glows when you touch it, and it drops this stuff when you mine it. So, let's get started. Okay, so here we go. Redstone ore. The magical block. So you see that on the ground, you step on it, it glows, you touch it, it glows, you mine it, it glows. It glows anytime it gets an update. Really neat. Then, you take a pickaxe to it, and you get that. That little guy right there. So, knowing that, you've got this redstone dust. This is your redstone wiring. This is the workhorse that's going to transfer most of your power. It'll take it all the way off yonder and get your power where you need to get it to. Next, we've got the redstone torch. Now, the torch is a power source. You put dust next to it, boom, it powers it. You put a repeater next to it, boom, it powers it. Comparator, boom, power. This little guy is a source of power. Next, we've got the repeater. Now, this little guy right here is really important. So you can take your power and run it straight into the back of a repeater, and then output out the front of the repeater. Now, the fun thing that the repeater does is it will extend a signal. So, redstone dust can transfer 15 blocks worth of power before it reaches 0 and doesn't transport power any further. So if we count this up, 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. So, if you turn that on, see power goes all the way to the end. And that does not glow. That glows, that does not. This has a power of 1, this has a power of 0, because it counts down from 15 all the way down. So, if I was to put an output here, such as redstone lamp, you're good to go. It'll turn it on, not a problem. But, let's say my redstone lamp, I want it to put there. Well, now what am I going to do? This is where the repeater comes in. The repeater will extend a signal once it's outputted out the front. Now, the nice thing about this is it will re-strengthen the signal, because see, you got these little torches in it. So I would treat that like it is taking its input here and going, okay, another torch, boom. So if you go 15 and get the repeater, it will do another 15. So this is obviously really useful for getting your signal from A to B when A is here and B is way over there. Now, another fun aspect of the repeater is, you see this little bar here? You can actually right-click on the repeater and push that second torch back. There's a couple of spots there. So, the repeater not only repeats the signal, but it can also have a tick delay set on it. Now, in Minecraft, you've got Minecraft ticks that are 0.05 seconds, or 20 Minecraft game ticks per second. Now, that is different from redstone ticks. Redstone ticks every 0.1 seconds, or every tenth of a second, so 10 redstone ticks per second. So that means that right here, anytime a signal comes through a repeater, it gets a 1 tick delay as the power moves from that torch to that torch and then continues on. Now you can right click on this and extend that delay, so now it would be 2 ticks, 3 ticks, 4 ticks. So that means that 0.4 seconds would pass before this power moves to this power, before the power state changes. So next is the comparator. It functions similarly to a repeater. As you can see, it looks similar, but not quite the same. So a comparator does exactly what the name says. It compares signals. So if we've got this coming in, which is 15, 14, 13, 12, 11, 10, 9 coming out in the back here, then since it's not getting any other input anywhere else, it should output exactly what it gets brought in the back out the front. 1, 2, 3, 4, 5, 6, 7, 8, 9, and not 10. So see, it has taken its input and compared its inputs and outputted an answer. So this right here with the torch at the front being blank, see how you got up, down? With that being off, this is in comparison mode. And now comparison mode takes the input at the back and compares it to the inputs at the side. You can input from both sides. What it will do is it will compare the back, and if the back is greater than or equal to the side, it will output the back's power. So if I've got 9 here, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and I pop that in there, since the back is greater than or equal to the side, it will output 9 blocks worth of power out of the front. The next mode that a comparator gives you is subtraction mode. So if you right click on the comparator, it'll put it into subtraction mode. And that means it will take the side input and subtract the back input. And whatever the difference is what it will put out the front. So if we've got this line coming in and it's submitting 5 power to the side, and this line is submitting 9 power to the back, subtracting that, the difference is 4. So that's what's output right here. Okay, so as I said earlier, repeaters and comparators, they all have tick delays. So if this is on 1 tick delay, every time it transfers power, it's tick, 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 and that'll add up. Now, comparators do the same thing. So to demonstrate that, I've lined them all up. Everything is set to 1 tick on the repeaters, so it's all just as it's placed. And you can see that tick delay demonstrated when you put a bunch of repeaters in a row, and you can see they unpower at the same sort of rate. So it's a tick between powering and a tick between unpowering. Now this can be changed if I go through and I whack a bunch of the repeaters, set them to 4 tick delay. So now that they're on 4 tick delay, if I turn this lever on, you'll see a big difference in the transfer of power. Because now each one is 0.4 seconds, or 4 ticks. And the difference is huge. So repeaters are your timing workhorse. Alright, so you don't always want to get power from there to there on a flat plane. Sometimes you want to transfer your power up. So obviously the easiest thing to do would be to just stair step your redstone right up to the top. Boom. I do that. Pop a lever down here. Pop a output on this side. Boom. You've got your power. You made it up. Not a problem. But that takes up a pretty large footprint to get from A to B here. You know, to go this distance, you have to use all of these blocks right here to get there. Whereas using dust and torches or an other method, you can do that with a lot less fuss. So, to go the same sort of distance, just like that. Alright, and let's move our output over here. Okay, So you want to get from here to here. So there's two types of power. There's high power and low power. So this dust is supplying this block that it's touching. Since it's running into this block, it is supplying this block with high power. So if we put a torch on top, the torch, since it is directly touching this block, would be receiving low power. Similarly to dust on the other side, if this was a repeater. See how it transfers high power, low power. So this actually gets powered at 15 power right there. Now that doesn't work with a dust on the other side of the block, but a repeater will transfer through. So if we continue to use the dust here and put a torch on top, boom, it powers the torch and the torch's state changes. If you input power to a redstone torch, its state changes. It doesn't always turn on or always turn off. Whatever state it was in, it flips to the other one. So then if we pop a block on top of it, and then another one, that one is on. So I flip this lever, the bottom torch's state changes because it's no longer receiving power. And so since that is on, it's supplying high power to this block and low power to this torch, so the torch's state changes. It turns off, and so does our output. Alright, so say you want to move power from down here to up there. There are a couple of other ways to do so that could be better because, as we know, torch state changes cause a tick delay. So if you watch, when I flip this lever, it's not quite as immediate. See that small delay between flipping the lever and the actual light turning off, whereas with the dust, that delay is a lot smaller because there's this delay for every time a torch has to change state and pass that new information up the line. So what we can do is we can use blocks like glowstone and the top side of a slab. See how it's placed along this, even to the top side of the block, can transfer energy up, 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 up. You can zigzag back and forth. Now this only works to go from down low to up high. You can't go down with it. You can only transfer energy up. Because the problem with redstone wire is if I've got a line like this, and I want a line right here, see how they connect? So what you would have to do to stop that from happening would be to put it up on its own level. It still connects, but you can break that connection by putting a block between them. See how it's cut the connection? So you can have two wires running next to each other, just like that. These blocks, however, do not do that to dust moving vertically. So if I turn this on, you can see that even though they're not really connected, they're still passing power up and turning the lamp on. Same thing over here. They're technically cut, but because this block is not considered a completely solid block, it will pass the energy up. This is really useful in some designs. Now there's another new-ish method of transferring power vertically, and that is using slime blocks. So you can set up a piston as your input, and slime blocks can be pushed, and they will move anything that they touch directly, except for certain blocks such as droppers and furnaces and things that are tile entities or obsidian. And then if you pop a redstone block at the top, which as I said earlier is movable power source, when I flip the lever, the piston will push up and it will push all of this up and light the lamp. Now, once the lamp is lit, most pistons by themselves, if I pulled this back and turned it off, the piston would retract, and if it was a sticky piston, it would grab the next block, but that's it. But since the slime blocks, if we pull that, the whole thing comes back down. This is really nice for making huge towers to move power vertically if you want to go way up in the sky, and this is relatively cheap you've got 9 dust to get the block, and then slime, you can make a farm for those, and you're good to go. So without going into practical applications too much, I want to demonstrate one thing which is really important for the transfer of high and low power for repeaters. So if I've got an input here, and say I want to transfer that power to go, say, right here, but this is the wall of my base or something. Not a great demonstration, but it'll serve the purpose. So in order to get power up there, if you don't really use redstone to its fullest capability, you'd probably end up doing something like this, which doesn't even work because of the placement of the lamp, because the dust is facing this way instead of actually touching the lamp. So with that being the case, you could pop one on there, not a problem, but this is kind of clunky. So what we would rather do is use repeaters a little more cleverly than that. So we can actually use a repeater to get power to go up and directly over without having to stair step around. If I put a repeater in there, we know that we high power this block. So then we should low power anything touching it, because it's a repeater, it will pass through. Boom. Got a dust there. You could even put a dust there, dust here, dust here. A repeater will transfer the power through the blocks, so will a comparator. So, to do this quick and easy, dust, 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 dust. And you've moved the power from there and directly back over itself using a repeater to pass through that block. Alright guys, so that was just the briefest overview of redstone components, so that should be enough to let you know exactly what's out there as far as the components go, how to craft them, what they're used for, and in future episodes we'll get into actually using them for more than just little demonstrations. So be sure to come back next time where we talk about logic gates. Really simple little logic gates. Go really easy on those. That will really benefit your builds and show you how to change states and manipulate redstone in a way to give you things that you might not have thought were possible. So thank you very much for watching, and I'll see you next time.